I'm going to speak about psychedelics and morphic resonance, and some of you know about morphic resonance and some of you don't. So I'm first going to have to talk a little bit about the hypothesis of morphic resonance and then show how this is related to psychedelic experiences. Morphic resonance is a hypothesis about memory and nature, and the basic idea is that there's an inherent memory in all nature. The so-called laws of nature are more like habits. Each species has a collective memory. Every individual tunes into that collective memory and in turn contributes to it. This leads to a very different interpretation of many phenomena, including inheritance, cultural inheritance, and indeed psychedelic experiences. So I'm going to say a little bit about the hypothesis and why I think we need this hypothesis. Until 1966, most physicists believed that we lived in an eternal universe. They thought that the universe had always been there and that it was governed by eternal laws of nature. The idea of eternal laws of nature, mathematical laws, is a very old idea. It goes back to Pythagoras. Plato loved the idea because he thought that ultimate reality was timeless, outside space and time. And most mathematicians and physicists today still believe that the laws of nature are somehow in a transcendent mathematical realm beyond space and time. This was the universal assumption, almost universal assumption, until 1966 within the sciences. But in 1966, there was this huge revolution in cosmology with the Big Bang theory. The idea was that the whole universe came into being less than the size of a head of a pin, very hot, very small, and it's been expanding and cooling down ever since. And as it grows and cools down, more and more forms and structures arise within it. It's much more like a developing organism than an eternal machine, which is what the old cosmology had. And most scientists believe that all the matter and energy in the universe suddenly appeared at the moment of the Big Bang, along with all the laws of nature. As my friend Terence McKenna used to say, modern science is based on the principle, give us one free miracle and we'll explain the rest. The one free miracle is the appearance of all the matter and energy in the universe and all the laws of nature from nothing in a single instant. Anyway, as a result of this cosmology, what we have is a radically evolutionary universe. We have a universe that's been evolving for 14 billion years and is still expanding and evolving. New things are happening all the time. New structures are coming into being. So the idea that it's all governed by eternal laws, does that really make sense in a radically evolutionary universe? As soon as we question it, we realize that the idea of laws of nature is very anthropomorphic. Only humans have laws. In fact, only civilized societies have laws. Tribes have customs. So the idea of laws of nature is a questionable concept to start with. And if we realize it's an analogy with human laws, it's a metaphor really, then we realize that human laws do actually evolve. If we have laws of nature, why shouldn't they evolve in an evolving universe? But better is the metaphor of habit. I think that the so-called regularities of nature are more like habits, and that these habits develop over time, that they persist because there's a memory in nature. As Terence once summarized it, things are as they are because they were as they were. So new things have to happen. There has to be creativity. But once new things have happened and been repeated, the more often they happen, the more habitual they become. This applies to all self-organizing systems: atoms, molecules, crystals, cells, tissues, organs, organisms, societies of organisms, cultures, planets, solar systems, galaxies. At all self-organizing levels, there are habits that build up, and there's an inherent memory that enables these habits to be remembered. Now, I'm not the only person to suggest habits of nature. The American philosopher C.S. Peirce suggested this idea around 1900. The contemporary cosmological theorist Lee Smolin has also come up with the idea of habits in an evolving cosmos. What the hypothesis of morphic resonance is an attempt to explain something about how these habits work. The word morphic comes from the Greek word morphe, meaning form. So it's about forms or patterns or patterns of organization. And resonance is about vibratory patterns of organization. Everything in nature is a vibratory pattern of organization. Atoms, molecules, crystals, they're all vibratory or rhythmic patterns. And so are we. We have numerous rhythms in our bodies: heartbeats, breathing rates, brain waves, daily cycles of sleeping and waking, biochemical rhythms that are very fast, all kinds, a kind of symphony of rhythms. And what I'm suggesting is that similar patterns of vibratory activity are influenced by previous similar patterns across time and space. These patterns are organized by what I call morphic fields, organizing fields. The fields are within and around the system they organize. My morphic fields are in and around me. But the morphic resonance that enables patterns of activity, information to be transferred from similar systems in the past, in this case similar people in the past, that is not local. It travels across space and time. Anyway, that's the hypothesis. And it can be tested in all sorts of ways. It applies to crystals. This hypothesis says that if you make a new crystal for the first time, it might take a long time for it to crystallize because there haven't been any crystals of that sort before. But after you've made those crystals, it should get easier to make the same kinds of crystals, and the more often you do it, the easier it gets. Well, this is well known to chemists. New compounds are generally very hard to crystallize. They take weeks, months, even years before you can get crystals. As time goes on, they get easier to crystallize. And this is one of the areas this hypothesis can be tested. It also predicts, as I describe in my book, A New Science of Life, in the current edition, the third edition, it also predicts that melting points of new compounds should go up, and indeed they seem to. The hypothesis applies to biological development. If fruit flies develop abnormally, then the more often they do it, the more easy it should be for that abnormality to appear again. And again, there's evidence for that, which I summarize in my books, New Science of Life and The Presence of the Past, that happens. It applies to animal behavior. If you train rats to learn a new trick in London, rats all around the world should learn the same trick quicker, just because the rats have learned it here. And this should happen straight away all over the world. In New York, in Melbourne, Australia, the rats should all learn it quicker if we train rats to learn a new trick here. And again, surprisingly, there's evidence from a long series of experiments this really happens. The same applies to humans. It should be getting easier to learn computer programming, skateboarding, windsurfing, all the new kinds of skills that people are learning should be getting easier to learn by morphic resonance. And again, there's evidence from actual experiments on people that this seems to be happening. Perhaps the most persuasive evidence comes from IQ tests. I predicted in the 1980s that IQ test scores should be going up on average because so many people have done IQ tests, not because people are getting smarter, but simply because the tests are getting easier because millions of people have done them. And it turns out just that is going on. It's now known that IQ scores on average have gone up about 30% over the course of the 20th century. Not because people are smarter, there's no evidence for that. They're just getting better at doing these standardized tests. When my older son was doing his school examinations, GCSE exams taken by 16-year-olds here in England, he came to me one day before the exams and said, my friends and I have thought of a great way of doing better in our exams without doing extra work. And I said, well, how are you going to do that? And he said, well, by morphic resonance. So I said, well, how will that work? He said, well, he said everyone does them in a synchronized way all over Britain to prevent people cheating by telling other people the questions. So it's all synchronized. He said, in the physics paper, there are 15 questions. He said, we're going to do questions 14 and 15 first, then go back to question 1, 2, 3. We'll be about 10 minutes behind everyone else in Britain on most of the questions, so we should get a boost by morphic resonance. Well, a great idea. I did say to him, well, some of your friends must have been morphic resonance skeptics. And he said, yes, indeed they were. And I said, what did they say? He said, they said, what if morphic resonance doesn't really happen? They worked out that if it doesn't really happen, they wouldn't lose anything. If it did, they get a boost. So they all did it, and they all got starred A's. I mean, they might have got them anyway, not a controlled experiment. It turned out a friend of mine from Cambridge, an old friend, happened to be in charge of the school science exams for the OCR board, the Oxford-Cambridge Board of School Examinations. And I said to him, look, here's a fantastic opportunity to test morphic resonance in a randomized subsample of these. Just change the order of the questions, and we can see if people over the whole country, a randomized subsample, do better when they're answering them after other people. At first he thought it was a great idea, but then he rang me up a few days later and said, Rupert, I'm due to retire soon. I want to make sure I have a full pension. If I turn our school science examination into a massive morphic resonance test, that's not going to happen. So unfortunately it didn't happen. But anyway, it's one of the potential experiments that could be done to test it. Now, this hypothesis leads to a great many predictions. One is, it means that normal biological inheritance doesn't all depend on genes or even on epigenetic modifications of genes. Genes account for only a small part of inheritance. They account for the proteins we can make. And that's important. We have to have the right proteins. Defective proteins can give genetic defects like cystic fibrosis or sickle cell anemia. But I don't think genes control the form. They don't control the shape of your arms or your legs or your face or the shapes of the feathers on a bird's wing. And they don't control the instincts, the ability of spiders to spin the right web for their species. I think all of these are inherited by morphic resonance. These are not protein structures. These are complex patterns of activity. So I think most inheritance happens by morphic resonance. It's now become clear that genes only account for a very small part of it. It's called the missing heritability problem, and it's a major crisis within the sciences. I discussed it in my most recent book, The Science Delusion. Now, I won't go into the details here, but I'd just like to say that the same applies to the inheritance of instincts, and also when we look at identical twins, we get a completely new spin on what's going on there. As you know, there's been a huge debate over a long period about the influence of nature and nurture, genes and environment, on human nature. Is it all determined by the genes, or nearly all determined by the genes, or is it largely shaped by the environment? And this has been a politically polarized debate. People on the right like the idea it's all determined by the genes because it means we're born unequal and there's not much you can do about it. People on the left like the idea it's environmental because it means you can improve human nature through social reform and education. Well, the best way to test it is through identical twins separated soon after birth. And many studies have been done on identical twins who were adopted by different families, had completely different upbringings, and yet the same genes. Those show astonishing similarities, even if they've never met each other after they were a few weeks old. Sometimes they even call their kids by the same names, have the same mannerisms and habits, same colored paint on their garden seats, and so on. I mean, things that you wouldn't expect to be coded in the genes. But these great similarities have led people to say, well, this must be because it's all genetically programmed. And the selfish gene theory, sociobiology, all rest on this foundation. But if morphic resonance is happening, most of these similarities could be explained by morphic resonance between the identical twins, even if they're separated. And I don't think they show genetic determinism at all. So it's possible to interpret them in a completely different way as evidence for morphic resonance. Of course, that's not the mainstream view. If we ask the question, who in the past is most similar to you, the answer is you. So the most specific morphic resonance based on similarity is going to be from your own past. I think we're constantly tuning into our own pasts. I think that's why our body forms remain much the same, though the chemicals and the cells within them change. And I think it's at the basis of our memories. I don't think memories are stored inside the brain, which is the conventional assumption, of course. I think we tune into them. I think our brains are more like video recorders than TV receivers. Now, again, this is a shocking idea if you're not familiar with it, but it fits the evidence much better than the brain trace theory of memory. People have been trying to find these traces for a very long time, and they've had very thin pickings in these results. The evidence is not overwhelming at all. It's simply an assumption. They must be in your brain. Where else could they be? I think actually morphic resonance is the basis of memory. Now, when we turn to psychedelic experiences in the light of these ideas, it immediately becomes obvious that a new way of interpreting them is possible. If you take a psychedelic that other people have taken in the past, then your brain is affected in a similar way to their brain. Same kinds of chemical changes, same kinds of neurological, neural activity changes happen in your brain as happened in theirs. It sets up perfect conditions for morphic resonance. So, say you take ayahuasca, then you would resonate morphically with all the people who've taken it before. If it's a particular brew, you'd resonate more with people who've taken that particular brew. But there'd be a generic resonance with all those who've taken it before. If you take LSD, you'd have the same kind of effect. This means that the history of the use of these compounds becomes extremely interesting. LSD was first synthesized in the when was it, 50s, 40s? Well, whenever Albert Hofmann first made it, it had never been made before. Something similar may have happened to people who got ergotism in the Middle Ages from ergot fungi, because it's related to that. But a whole new range of experiences started to happen. At first, they happened mostly by medical researchers. Then, of course, LSD became a popular part of the counterculture and was taken under a great range of different circumstances. And people who take it today would be tuning in to this enormous range of experiences that people have had with LSD since the 1960s, well, since before the 60s. If you take cannabis, then you'd be tuning in to a long history of cannabis use in countries like India, where it's been smoked as part of a devotional exercise by sadhus and others for millennia. If you take ayahuasca, coming back to that one, you might tune in to the experience of people who've taken it in Amazonian cultures over hundreds or thousands of years. And you might then expect that some of the cultural flavors of that experience might come through. One of the things that many people in those traditional cultures report is visions of serpents or jaguars. And in a fascinating series of experiments, the only kind I know that were actually done to look at this, well, not necessarily directly to look at this, by Claudio Naranjo, who did these experiments, I think with harmaline rather than the ayahuasca brew, with urban patients who knew nothing about Amazonian cultures. They started having visions of black jaguars and snakes. Now, I don't think that's because the molecule harmaline triggers off some jaguar cell inside the brain, causing jaguar visions. I think it's because these people were, without knowing it, tuning in to the collective experience of people where this culture, this had been part of their culture. So I think that this particular kind of experience suggests that there is a kind of cultural inheritance involved in taking of psychedelics. And this is, of course, a speculative interpretation, but it makes sense to me, both in the light of the general facts and also my own experience. It's also a testable hypothesis. I was once at a symposium at Esalen, at the Esalen Institute, with Terence McKenna and Sasha Shulgin and a whole range of other people. It was called Psychedelics and the Observer Effect. Terence McKenna was talking about what he called hands-on pharmacology. And we were discussing designer drugs with Sasha Shulgin, who was the archetypal designer of designer drugs. And I said to him, when you've made new drugs, how do you know what they're going to do? And he said, well, I don't. He said, we have a taste. He said, I take them myself first. And if it's not toxic and if it's not too unpleasant, then I have a tasting panel of about 12 people. We take them and we share our experiences, and a kind of consensus builds up. And I said, well, are they quite varied at first? He said, yes. And then a sort of consensus reality emerges. And then when other people take it, they seem to get this kind of same consensus view. And that gave me the idea for an experiment. If you have a new psychedelic, you could have a range of, say, 10 different potential scenarios in which it could be taken. You know, Japanese-type decor with sort of paper screens, you know, psychedelic environment, you know, outdoors in nature and in the Canadian mountains. There could be a range of environments that you could, all very different from each other. You could select at random one of these, have the first 100 or so people who take it in that kind of environment, and then have other people take it blind, as it were, not knowing the background, and see whether they get, if it was taken in Canadian mountains, whether they get visions of Canadian mountains and coniferous forests and that kind of thing, and mosses and ferns and babbling streams. Or if it was taken in the Japanese setting, whether they have sort of Japanese type experiences. Now, if that happened, it would actually be an empirical test of this hypothesis. So I think that the main point really for people who take psychedelics is to realize that you may be experiencing something that's not just an individual experience caused by molecules affecting your brain, but as in all our cultural inheritance, everything we have and do is culturally shaped. Our language, everything about our culture we inherit from other people. We also inherit these experiences. And if they're taken in particularly culturally shaped forms, for example, ayahuasca taken in a shamanic, Peruvian shamanic setting, would have a different cultural frame from the same or similar mixture being taken in the Santo Daime church. The songs that are sung, the cultural setting, will tend to shape the experience in such a way that you tune into it. This is true of rituals in general. Morphic resonance applies to rituals in general. Every time anyone does a ritual in any religion or in any secular context, like the American Thanksgiving dinner, in rituals, people deliberately do things the same way they were done before, similar language, similar gestures. Rituals are highly conservative. And I think the reason they're highly conservative and the reason that all cultures have them is that by taking part in them, by doing it as similarly as it was done before, there's a literal presence of the past, a tuning into all those who've done it before. And people in these rituals actually believe that's what's happening. When Jews celebrate the Passover, they believe they're connecting not just with the first Passover, but with all those who've celebrated ever since. The same with Christians and the Holy Communion. And I think this applies to these ayahuasca churches or to shamanic rituals or other ritualized forms of taking psychedelics, that these rituals help shape the experience by tuning you in to those who've done them before in that context. I think that there's one more final point, that the experiences we have are not just open to people, open to the experiences of people in the past and influenced by them, but we are influencing those who will come after us. So it does mean we have a certain responsibility. Do we want our LSD trip or our ayahuasca experience to have a bad effect on people who come after? Well, no, we probably don't. We want it to have a good effect, and I think it's important to go into these experiences realizing that it's about more than just us. And after all, many of these experiences do give that exact feeling. This is about something much more than just me. But I think it affects other people, and so I think that taking them in a way that keeps that in mind helps us do it in a more responsible way. Thank you.